Good morning, everyone. I'm Anil Kumar from Toronto, Canada. And today in advanced functions, we are going to do how do we divide polynomials. So we'll see long division and synthetic division. Okay. So can you please introduce yourself one by one, Mohammed?
Hello, I'm Mohammed Hosseini. I'm from Oakville, Ontario, and I'm going to grade 11. I'm taking this course to try to get a better understanding and prepare myself for the future.
Ankita.
Hi, my name is Ankita. I'm from Brampton, Ontario. I'm going into grade 12. I've actually never heard of long division with polynomials, so I'm quite excited for this class.
Hamza.
My name is Hamza. I'm from Oakville, Ontario, and I'm really excited to learn from this class so I can get a better understanding when I go next year.
Akshay.
Hi, my name is Akshat Kandivanam. I'm currently going into grade 12, so I thought it would be best to visit advanced functions.
Vishruta.
Hi, my name is Vishruta. I'm going to grade 11 and I'm doing advanced functions to prepare myself for next year.
Great. So let's begin our lesson. It is polynomials, as you know, and we'll focus on polynomial division. So we'll cover these topics today. Can you all see the screen, right? Introduction to polynomial division, division statement, division by binomial and restrictions, division by trinomial, arrange terms in correct order. That is very important key thing when we divide polynomials. And we'll also see how do we divide polynomials when some terms are missing. We'll look into synthetic division, which is kind of a shortcut method of long division. And we'll understand questions related to divisor, quotient, remainders, right? So we'll also discuss some communication and thinking questions in today's lesson. So let me just begin with a very simple division statement. For example, what I've shown here is we are going to divide 7 by 5. So if you divide 7 by 5, what do you get? I hope remember the signs, right? We're dividing 7 by 5. It goes one time, and 1 time 5 is 5. When you take away 5 from 7, you get remainder as 2, correct? So these terms, 5 is called the divisor, 5 is the divisor for you, 1 is the quotient, correct? 2 is the remainder. And the number 7, which was being divided by 5, is called dividend, right? Now we could write a division statement, that is, we wanted to divide what? 7 by 5, correct? So 7 by 5 is equal to quotient, which is 1, plus remainder 2, right? Or rather, I should write not like this. We normally say quotient and remainder 2, right? We write 1, which is quotient, and with remainder 2. But actually speaking, we will write this as 7 over 5 is 1 plus 2 over 5, correct? Is this part clear to you? So we still have to divide 2 by 5, right? So 7 over 5 is 1 plus 2 over 5. Is this part clear to everyone? Correct? If you do the right side, so if you take 5 as a common denominator, what do you get? You get 5 plus 2, which is 7 over 5. Is that clear to you? So both sides are equal, correct? You could also write this statement in slightly different way. That is, you can write what is 7 equals to. We can say 7 is equals to 5 times 1 plus 2. Correct? So the division we could write as a multiplication also, 5 times 1 plus 2. Is this part clear to you? Well, both of them are called the division statements. We do polynomials kind of same way. See how. So what we will do normally is that we'll take a polynomial. Let's call this polynomial as p over x, px. We'll divide with the divisor d. When you divide, you will get some quotient, correct? And in this process, you will get some remainder. Looking into what you saw, we could write this as a division statement, which is a polynomial p of x when divided by the divisor d of x will give us what? A quotient. plus remainder means we still have to divide by the divisor, right? Correct? Of course, the divisor cannot be 0. You cannot divide by
I have a
0.
question.
Yes.
So if we're doing like an equation, like a polynomial equation, and we divide it and then we get a remainder, how do we write that? Like, do we just do R, like I remember in grade 2 when we had like a remainder, we just do R1 beside the answer. How would we do that for like polynomials?
I'll show you. Well, I'll show you that also. We'll write like this, remainder over that divisor. If I multiply everything by the divisor, what do I get? I get the polynomial p of x as equal to what? This gets multiplied by the divisor. So I could write this as quotient times divisor plus remainder. We could write like this in the form. Do you see that? So answering to your question, Hamza, the polynomial can be written as product of divisor and the quotient plus the remainder. Is that clear? So that becomes our division statement. So we'll take up an example. Let us say that, let me write down some polynomial, right? X cubed plus, I'm just vaguely writing, right? 2x squared plus x minus 5, let us say. And let's say we divide this by x minus 1. So if I divide with x minus 1, how should I proceed? Well, I should first take care of this number, right? So it goes how many times? If I multiply this with x squared, in that case, multiplying by x squared, both of them, I get x cubed minus 1 times x squared is x squared. So the term in the quotient will be x squared first, mainly because I would actually divide x cubed by x, and whatever I get, I'm writing here. Do you see that? Because I want to take care of terms one by one, starting from the leading term. Is that okay? That is the process to be followed. So what we realize here, since x cubed over x is x squared, the first term is x squared, okay? So what we did was that we multiplied x minus 1 by x squared, because that is what you will do, right? And so you get x cubed minus x squared. Is that clear to you? Once you do that, then you have to take away. So what is the difference? This becomes 3x squared. 2x squared minus x squared. That means 2x squared plus x squared, right? Just as you do in long division. And now we'll bring down the other term, which is plus x. So bring the next term down. Now what will you divide by? Well, we have to take care of 3x squared. So 3x squared divided by x is basically 3x, correct? So we will write here plus 3x. Multiply everything by 3x. And when you do that, you get what? You get 3x squared minus 3x. Is this clear to you? And then find the difference. So when you find the difference, x minus 3x means it becomes 4x, right? And bring down 5 with a negative sign as given here. And next number, can you tell me what should be my next number here in the quotient? Anybody? I have to take care of 4x, right? So I should multiply here by 4. So 4 times x is 4x, and minus 1, 4 minus 1 is 4, and the remainder now is minus 1. Do you see this? So that is how we are going to divide the polynomial. And now let me write down the division statement in the multiplication form. And as Hamza had a question, we have a remainder this time. So we can say, well, x cubed plus 2x squared plus x minus 5 is equal to what? It is equal to quotient times the divisor. You could write like this also. X minus 1 times x squared plus 3x plus 4 minus 1, which is the remainder. Now, is this step absolutely clear? Any doubts?
Sir?
Yes.
Sir, I just had a question. So
Yes.
when you're doing actual long division, you can't have -1 is the remainder, but when you're doing polynomial, you can because the -1 affects the entire answer, right?
Yeah, -1, and the remainder will be 1 degree lower than the divisor. So here we could have any number. We could also have 0. If we get 0 as a remainder, that means it is a factor. Is that okay?
Okay, yeah.
X minus 1 is not a factor of x cubed plus 2x squared plus x minus 5. Now you can always check if our result is correct or not by expanding, applying the distributive property and then combining the like terms. Okay, so that is how we actually do all this. Now, here is a quick check. I will tell you the method first. How do we check whether a remainder is correct or not? We actually divided the whole thing by x minus 1. And we got some remainder. Now, when is x minus 1 0? It is 0 for x equals to 1. So basically, if I look here, if I put x equals to 1 here, then what happens? Tell me. If I put x equals to 1, in that case, what happened? Then x minus 1 is 0. Do you see that 0? So anything by 0 is 0. I get minus 1. Do you see this? If I substitute x equals to 1, I get just minus 1. Is that okay? Now, left-hand side should also be same. Only then both are equal. So let me substitute 1 here. So on the left-hand side, 1 cube is 1 plus 1 times 2 plus 1 minus 5. What do I get? 1 plus 2, 3. 3 plus 1, 4. 4 minus 5, minus 1. Do you see both are equal? Correct. So we got the value of the function polynomial for 1 is equal to minus 1, which is actually the remainder. Do you see that?
Sir?
Yes.
Sir, this would be the case for any other value too, right?
Any polynomial, no, only one which will make it 0.
Okay, only one should make it 0.
Yes. So we call this as a remainder theorem. This is called remainder theorem. So to find the remainder, I don't really have to divide and then find out what the remainder is. I could just substitute a value and find the remainder. You get the idea? So this is called remainder theorem. We'll take more examples and then we'll see how to work it out, right? So anyway, first let me revise what we just learned. One thing, that if a polynomial is divided by the divisor d of x, we get a quotient and a remainder. This could be written in a statement, which is that polynomial is equal to the product of divisor and quotient plus the remainder. Or you could also write this as the quotient of polynomial and the divisor is quotient plus remainder divided by divisor. Correct? So that is our division statement, right? Many times after dividing, you have to write down the division statement. So it is important to remember it. Okay, now let's do one more example. Now, before we do this example, let us see what should be the remainder. Tell me. I'm going to divide 2x cubed minus x squared plus 3x minus 5 by x minus 2. If I have to find what remainder I'm going to get, what will I do? Well, I will just substitute 2 here, right, in the polynomial. And if I substitute 2 here, what do I get? I get 2 times 2 cubed minus 2 square plus 3 times 2 minus 5, which is how much? 2 cubed is 8. 8 times 2 is 16. Minus 4 plus 6 minus 5, correct? And if you do this, what do you get? 16 minus 4 is 12. 12 plus 6 is 18. And from 18, if you take away, then you get 13. Is that clear? Correct? So we are expecting 13 as our remainder. Let us do all the calculations and check. Do we really get 13 as the remainder? So we will actually prove the remainder theorem in a different way, right? Okay. So let's do our long division. So long division like this. We have all the terms here. Let me write down the terms, which are 2x cubed minus x squared plus 3x minus 5. We are going to divide by x minus 2. So what should be the first? There are 2 terms, so I'll involve 2 terms, correct? I'm dividing by a binomial, so I'll involve 2 terms. So what should be my first term? in the quotient? I have to divide 2x cubed
So
by x.
you would divide 2x cubed by x.
So you get 2x squared, correct?
Yeah.
So now you'll multiply x
The
minus
2x
2 by
plus
2x squared. So what you get is 2x cubed minus 4x squared. Is that clear? Then we take away. So when you take away, you get 3x squared, right? Minus 4 becomes plus 4, right? And bring down the next term, which is 3x. Now what should I get in the quotient? 3x, correct? So multiply by 3x, 3x squared minus 3 times 2 is 6. Now if I take away, then I get 9x minus 5. Next time, I should be multiplying by 9. That gives me 9x minus 9 times 2, 18. And if I take away, what do I get? I get plus 13. Do you see that matches? So we could actually find the remainder without actually doing the long division. Do you see that part? This is a very important part because it tells me that x minus 2 is not a factor of this given polynomial, right? Because you're getting a remainder. But if it was a
So
factor, yeah.
I don't get the first step. Why did you substitute 2 like p over 2 equals to 2? I didn't really understand that. I understand the long division part, but how do you do the first step? What do you
We are
substitute? to
dividing
get the
by
remainder?
x. We are dividing by x minus 2, right? So I'm just trying to tell you that the remainder theorem is, which you haven't learned yet. We will be learning it soon. We learn it by doing so many questions that you check what is the remainder. This remainder is always the value of the polynomial at, if you're dividing by x minus a. So let me write in general. If there is a polynomial p of x, and if I'm dividing this polynomial by some factor, let's say x minus a, in that case, what is the remainder? Remainder is the value of the polynomial at a. You get the idea. Remainder is the value of the polynomial at a, because that is your factor. I
Sir?
mean, if it is 0, then it is your factor. Otherwise, that gives you the remainder. Yes, please.
Sir, so it's just whatever makes a 0, right? Whatever value
X
makes
minus a 0, yes.
x minus a.
Is this part clear to you? I'll show you once again using division statement why this is correct. Now let me write the multiplication division statement. I will say multiplication, but anyway, it is the division statement. 2x cubed minus x squared plus 3x can now be written as equal to product of these two, which is x minus 2 times the quotient, which is 2x squared plus 3x plus 9, and the remainder 13, correct? Now see, if I put x equals to 2, what happens? 2 minus 2 is 0. If I put 2 everywhere, do you see that? Whatever is this plus 13, because whatever is this, that 0 times anything is going to be 0. What do you get? You get the remainder 13, right? Substituting 2. Does it make sense? This is the value of polynomial at 2, correct? Because this is my polynomial, right? So polynomial 2 is remainder because the quotient time divisor is 0. So this is called remainder theorem. You get the idea? Let me make it explicitly clear. What I'm saying here is that the polynomial p of x is equal to divisor times the quotient, correct? Plus the remainder. Is that clear? Now, if, let us say divisor is x minus a, right? It could be any linear divisor x minus a. That means what is p of a equals to? X minus a will be 0, right? A minus a is 0. So p of a is the remainder. Is this clear to you? Correct? Perfect. This is called remainder theorem. This is remainder theorem. Perfect. Now, if you have understood what is this long division, I would like you to do this particular long division quickly, right? So try to do it, and somebody, you can use your calculator and tell me what is the remainder expected? What is the remainder equal to? You can use calculator. Tell me what is the remainder. For remainder, what value should I put for x? Tell me.
So for x, wouldn't it be -1/2?
Yes, sir. Substitute
No.
-1/2 and calculate using your calculator. Tell me what is the answer you're getting. And we will check after doing long division. Any one of you calculate and tell me what you get. Yes. Is anybody doing calculation?
Yes, sir, I'm doing that.
Okay. Okay, Vishruta, tell me in the quotient what number should come first?
Sir,
Yes. 3x square. So continue. 6x cube plus 3x square, right? So I'm continuing with the division.
And I think you'd subtract.
Correct? And now what will come, Vishruta? Tell me.
The 5 would be carried down.
So now I should write half here, right? Correct? Because 6x cube plus 4x square minus x plus 5, when I multiply by 3x square, I get 6x cube plus 3x square and x square. X square divided by 2x will give me half x, right? So when now I multiply by half x, I get x square here, and half x times plus this is plus half x. And now when I take away 1 minus half is -1 minus half is minus 3 by 2, right? And I bring down 5. Akshay, did you find the remainder or no?
yes, sir, I found the remainder, but my calculator can be a little tricky at times, so I'm not too sure. But I got 5.75.
Okay, so because, yeah, 5.75, we are getting decimals. That is why I thought I will ask you. So now we have minus 3 by 2x plus 5. Now, what should I multiply this with? Well, of course, a negative term. And we want minus 3x over 2 is what? See? So minus 3x over 2. We have to divide this by 2x, correct? So minus 3. When you do, you get minus 3 over 4. Correct? So when you multiply with this, 3 times 2 and 4 is there. So you get minus 3 over 2x and minus 3 over 4. And now what is the remainder? We'll add these two, right? 5 plus 3 over 4, which is 4 is the common denominator, 20 plus 3, right? 23 over 4 is approximately how much? Maybe 5.75. Check.
Yes, sir, it is 5.75.
Do you see that? We found the remainder earlier and we did all our calculations. The calculations involve a lot of fractions. That could be a test question. Sometimes in the test, the teachers give you such numbers that you land up with, fractions after fractions. That becomes very difficult. It looks simple question, correct? Now, whenever you divide, it's a good practice to write that x is not equal to minus half. And that is the restriction. Do you see that? So whenever you divide, your denominator cannot be 0. Therefore, we have to write that x cannot be negative half. Is that clear? Okay. So that is how we'll do it. And I think we'll move forward. Here's the calculation which I actually had done earlier also. Now here is the third example for us. In this case, this example is slightly, interesting. Interesting because Akshat, can you please read this equation? What is the polynomial written here?
Yes, sir. 4x cubed minus 2x plus 7 divided by x plus 1.
Something is missing in between, right? X squared term is missing. So when you divide this, what are we going to do? We will place 0 for x squared terms. So we have here 4x cubed plus 0x squared minus 2x plus 7, and we are dividing by x plus 1. Now this is a very important step. We have something which was missing, 0x squared, right? That x squared term was missing. We call this as a placeholder. Why is it important? Because see, I have a binomial, right? So when I'm dividing by a binomial, I will involve two terms, right? Well, if I write under minus 2x, it will mismatch because I have x squared term. What will be in my quotient? Quotient will be 4x cubed divided by x, which is 4x squared, right? So when I multiply these terms with 4x squared, I get what? I get 4x cubed plus 4x squared. Do you see that? If I would not have written 0x squared, there would have been minus 2x. How could I subtract from minus 2x 4x squared? You understand? The whole thing will get misaligned. So just for alignment purpose, we place this placeholder. Is this part clear?
Sir?
Yes.
The placeholder doesn't affect that you can still find the remainder with
It's
just
the
plugging
same.
in.
0 will not change it, right?
Okay.
Ankita, do you understand this process?
Yes, sir.
Okay, so now let's subtract. So we get 4x squared, even if it was not there, when you take away 4x squared, it will be minus 4x squared, right? And the other term which we bring down is minus 2x. Now in the quotient, I should be writing what? Tell me. Vishruta, tell me, what should come here now in the quotient?
Negative 4x.
X. Don't forget x. Yeah, negative 4x. So we get negative 4x squared and negative 4x. And when you do take away, you get 2x plus 7. And now what will come? Multiply by 2, right? So we get 2x plus 2 and we get the remainder as 5, correct? So that is my remainder. Okay, Mohammed, I would like you to tell me how will my division statement look like? What is the division statement? Help me write division statement. So I'll start with this polynomial, which is 4x cubed minus 2x plus 7 is equal to what? Tell me, Hamza. Mohammed, yes.
Wait, what do you mean by the division statement? I don't really know.
We have to multiply the quotient and the divisor. X plus 1 times the quotient, which is 4x squared minus 4x plus 2 plus the remainder. Is that clear to you? That becomes your division statement. Now, tell me, Mohammed, please tell me, what is the value of polynomial p minus 1 equal to? If I set minus 1 here, what will I get?
Wait, is it the remainder or?
Yes, it is the remainder. You're right. Because the first term, x plus 1 will be 0, right? When I put minus 1 there, and you get the remainder. And this is what is remainder theorem. So do you check? Remainder theorem, right? You could substitute and check your result. 4 times minus 1 cube, let us check it, right? Minus 2 times minus 1 plus 7. What do you get? 4 times minus 1 cube is minus 4. That gives you plus 2 plus 7, right? And that gives you 9 minus 4, which is 5. Is that clear to you? So we do get 5, and we found this without doing long division. Why? That is the remainder theorem. Is the remainder theorem clear to everyone? So always, 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 if I'm dividing by x minus a, the value of the polynomial at x equals to a is the remainder. Is that clear? Okay. Now, here's another example for you. So I'm not going to write it, but do it, but I'll ask you questions. What should be the restriction on this particular division of polynomial?
X is not equal to 2.
Minus
negative 2.
-2.
What is the remainder of this function? Tell me. When I divide by x by 2, what should I get as my remainder? Calculate.
So I think it's -4.
Okay. So just do your calculation using the calculator. So minus 2 cube will give me 2 times minus 2 cube is minus 8 minus 5 times 4 plus and that minus 2 will make it minus 8
No, so I think
plus
it's
30.
-14 actually.
Okay, so do your work. Minus 16 minus 20 minus 8 plus 30. Is it okay?
Yeah,
Yeah. So what do you get?
-14, sir.
4 here, then it is 20, 20, 40. Pardon?
-14, sir. Is the
Minus
remainder.
14 is correct. Yeah, yeah. So you get minus 14. But I like you to do this division on your own. Simple division, all the terms are there. No need to for any placeholder, right? So that becomes your question number 1. Take it as a test. Now there is another important thing. We are dividing by polynomials, right? It can be trinomial, not necessarily a binomial, correct? So now let us see how do we divide with this kind of a thing. So we'll process the same. We have to divide 2x to the power of 4 plus x cubed minus 4x squared minus 2 by x squared plus 2x minus 3. So what should be the first term in the quotient? Anybody?
2x squared.
Perfect. So we'll just multiply everything by 2x squared. So we get plus 4x cubed, right? Minus 6x squared, take away. So that becomes minus 3x cubed. And that becomes plus 2x squared. There is a placeholder which is missing, right? Do you see? So I should have put here plus 0x, correct? And then minus 2. Do you see that? Because when I wanted to get the next number, it was missing. That x was missing. So you have to put a placeholder here. That placeholder, that position for x was missing, correct? So we placed a placeholder. Now we'll continue. Now what should be my next number? Tell me, Vishruta, can you tell me what is the next number in the quotient, please?
-3x.
You're right. So negative 3x cubed will be my first term, negative 6x squared, and that becomes positive 9x. Perfect. When you take away, this becomes 8x squared, and this becomes minus 9x minus 2. And now I should get here 8, right? So we get 8x squared plus 16x minus 8 times 3 is 24. And what do I get here? I get minus 25x, and this gives me plus 22. Do you see that? What is the order of my remainder? What is the degree of the remainder?
So would it be order 1?
Linear, yes, order 1. So it is linear, it has to be the remainder. Degree of remainder will always be how much? Less than the divisor, right? Otherwise you could divide it, correct? So that is very important to know, that the remainder will always be of degree n minus 1, where n is degree of divisor. Is that okay? Remainder is of degree less than y less than. It could be 0 also, it could be a number also, correct? There was a possibility that I would have got 9x, correct? So the highest degree could be n minus 1, 1 less than this. Is this clear? And again, this is not a factor. So we got so many terms which are not the factors. Now, we will also learn a formula of factoring cubes, difference of cubes using this particular division. So the question here is, I have to now divide x cubed minus 1 by x minus 1. What should be the remainder? Can anybody tell me what is the remainder in this case? That is
0.
yes. If I put 1 here, I get 1 minus 1, which is 0. So if 0 is the remainder, in that case, we will say that x minus 1 is a factor, right? Is that clear to you? So that becomes factor theorem. It says that if any polynomial p of x is divided by x minus a and remainder r of x equals to 0, then x minus a is a factor. Simple as that. Is this clear to everyone?
So you didn't have to just solve it at all. You just.
We will solve, don't worry. But we can say without solving that x minus 1 is a factor.
Oh yeah. Okay. Okay.
Very good. So let's continue. Let us see how do we really divide this, right? So we have x cubed minus 1 to be divided by x minus 1. So definitely there are two terms missing in between. So we should actually put those placeholders, correct? So when I divide, I will put x cubed plus 0x squared, correct? Plus 0x minus 1. And I'm going to divide this by x minus 1. So quickly, what is the first term? Of course, it is x squared. So we get x cubed minus x squared. And when I take away, I get x squared plus 0x. Next term is x for me. So I get x squared minus x. And when I take away, I get x minus 1. And the next term is plus 1. And therefore, we get x minus 1. And the remainder is 0 as expected. Clear? What is my division statement? Division statement is that x cubed minus 1 is basically equal to x minus 1 times x squared plus x plus 1, correct? So now you can actually divide and by this and then get your answer, correct? Now, general formula here is like this. If I have x cubed minus, let us say b cubed, 1 is 1 cube, right? In that case, I could write this as x minus b times x squared plus bx plus 1. So that becomes my general formula. It is your homework to prove that this is your general formula. Is that okay? So very simple. How will you prove it? You will just do x cubed minus, well, let me write 0x squared plus, right, placeholders, 0x minus b cubed, right? And I'm going to divide all this by x minus b, correct? And when I do that, I will get here x squared plus bx plus 1. Very simple. And all the steps, remainder will be 0. Do you get the idea? Exactly what I did earlier. And now I can write that this is the formula of a cube minus b cube. A cube minus b cube is a minus b times a square plus ab plus 1 plus b, sorry, b. Sorry, plus b. Plus b, right? So now we have general formula for x cube. Let me term, right? X cube minus y cube, let's say, right? In that case, it will be x minus y times x squared plus xy plus y squared, okay? And if it is x cube plus y cube, in that case, the formula will be x plus y times x squared minus xy plus y squared. That is going to be the formula, is b squared. Make a note of these formulas, because many times the question will be to factor difference of cubes or sum of cubes, and directly you can apply this formula and get the result. You get the idea. For example, if I have to factor, let's say 8x cubed minus 27, then what will I get? Well, 8x cubed is 2x whole cube minus 3 cube, right? So can anybody tell me how will I factor this? What will I get? Use the formula now. Long division also you can do. Yes, tell me. A minus b, which is 2x minus 3, times a square, which is 4x square, plus product of both of them, 3 times 2x, 6x, and plus 3 square, which is 9. Do you get this? Easy. You could divide and also write the division statement. You get the same thing. Is this clear to everyone?
Sir, I have a quick question.
Ask.
When in the formula we do x times y, right?
Yeah.
In this case, isn't it 2 times minus 3? Would we be counting the minus, or is it just 2 times?
That 2ab is not there. No, not 2ab.
Okay.
The formula is this one.
So it would just be plus 6x, right? Not minus 6x?
No, plus 6x. So this is correct. If you expand it, you'll get this. Okay.
Okay.
Okay. So to be very clear, let's go through our division process, right? So do you see we get plus x here? Right? The division
Yes, sir.
was perfect, correct? This 1 or 1 square is one the same thing, right? 1 square is 1, right?
Yeah.
Right. So that is how we do the long division. Now, we could do this long division in a shorter form, and that is called synthetic division. So let me just show you what synthetic division is. So we'll take up this example to teach you synthetic division. So what I should do here is that let me do both long division first, and then we will see what the synthetic equivalent is. Is that okay? Short form is. So let's divide this. We are now dividing by x minus 2. And what do we have here? We have 2x to the power of 4 minus 3x cubed minus 5x squared plus x plus 10, correct? Okay, let's divide. So when I divide this, first term should be 2 times x cubed, right? So that'll be 2x to the power of 4 minus 4x cubed. When you take away, you get x cubed minus 5x squared you're bringing down. Next term will be plus x squared, correct? So keep checking, right? So minus 2x squared. And this gives you minus 3x squared plus we bring down x and we get minus 3x. So we get minus 3x squared minus 6x. And that gives me 7x, right? Plus 10. So now I could do plus 7 here. And so we get 7x minus 14 and we get a remainder which is 24. Is this clear to you? All the steps. We'll check using synthetic division. Did we do it all right or not? Now synthetic division is kind of like this. See how neat method it is. We'll do the same thing, but see how. Okay. So we'll only write coefficients. Do you think most of the numbers are coming and the coefficients don't really play much role? So instead of writing 2 to the 2x4 and minus 3x cubed, I will only write the numbers which are 2, minus 3.
Sir?
Yes?
Sir, I don't know if I'm wrong, but we multiply minus 3x by x minus 2, right, sir?
3x by?
Minus 3x
x
by
minus
x
2.
minus 2.
Yeah. So we get
So wouldn't
minus
that be-
6x squared and plus, oh yeah. We got
It'd be plus
mistake,
6x, right?
plus 6x. Oh, good job. That is what I had a feeling that I'm going to do a mistake here. So I told you, check, right? You're correct. Thank you. You have to be alert, right? Oh my God. So 6x and this, when you minus, you get 12x. Is that clear now? Oh, right? So bring down 10. And when you multiply, we could have checked it. We'll see with long synthetic division. 12x minus 24, right? So we get what? 34. Now, am I correct?
Yes, sir. It seems to be. Yeah.
Okay, we'll check. Don't worry. Good job. So keep checking because I'm doing hurriedly. Okay. Now, 2 minus 3, we are only writing the coefficients. Minus 5, then coefficient is 1, and this coefficient is 10, right? We only wrote coefficients, right? Because, that is what we are working with mainly. Divisor, coefficient. So we are doing minus. Isn't it easy to do addition? So instead of minus 2, we will divide by 2. What makes this 0? Okay, so we will not do negative, we'll add the terms. So the method is like this. First thing, just bring down the number as such. So this 2, just copy it as such, 2, right? Then next step, because that is our first number, right? You're dividing by this number. So bring down the leading coefficient as such. Now, multiply 2 by 2. When you multiply 2 by 2, what do you get? And write it here. 2 times 2 is 4, correct? Add them. Minus 3 plus 4 is how much? 1, correct?
1.
Multiply 2 by 1, what do you get? 2. Add them. Minus 5 plus 2 is minus 3. Multiply 2 by minus 3, you get what? Minus 6. Add them. You get what? When you add them, you get minus 5. Multiply this by 10. So something wrong went there. So let us check. Something went wrong. So minus 3x minus 6x. Oh, this was x only, right? Sorry. You bring down x only, correct? And so you get, that was correct. Because you bring down this x, correct? So minus 3x squared plus x. And when you do this take away, you get 7x. This was minus here. When you take away, you get 7x, right? So earlier calculation was correct. And now, Akshat, is it correct or no?
Sir, yeah, it looks correct. Before we had something, instead of the x, we had something else, right?
Yeah, we had some. Now this is correct, right? Now look here. When we type the coefficients, 2, minus 3, minus 5, 1, 10, right? So this is plus 1. And now when we multiply, so plus 1 minus 6 is minus 5. Multiply 2 with minus 5, you get minus 10. And when you add them, you get what? You get 0. So something is wrong still.
Sir,
Minus 3. Yeah, ask, see, check.
sir, did we change it from minus 6 to plus 6 where it says minus 3x squared minus 6x? Because didn't we multiply minus 3x by x minus 2?
Minus 3x by 2 gives us minus 3x squared, and that gives you plus. Oh, yeah, this is plus 6. Yeah. Sorry. Yeah, you're right. So minus 3 times minus 2 is plus 6. Yes, plus 6. So now when we do it, you get minus 5x plus 10, right? Good, we are doing synthetic check with this also, so, minus 5. So when I multiply by minus 5, you get minus 5x, and you get plus 10, and we get a remainder which is 0. Now it is correct. Here also we got remainder 0. Do you see that? Everybody, are you with me on this? We did a couple of mistakes at this particular stage, and now finally, we see that synthetic division helped us figure out that there was a mistake. And that shortcut method, synthetic division, is that division method clear to everyone or no? Ankita, is this method clear to you? Let's redo it.
Yes, sir, it's clear.
Let's redo it. This is very important, okay? So what I'm going to do here is, we'll make division like a T chart, write all the coefficients. Coefficients are 2, minus 3, minus 5, 1, and plus 10. And the divisor
So-
is, yes.
Sorry to cut you off. I don't know if you've said this before, but you know how you've added the T-chart, right? Is this just a method of showing us how to do it? Or like if this question is given on the exam, doing the T-chart would actually help us and it's kind of required?
No, this is called synthetic method. No, T-chart is not the correct word. I'm just making it a T shape. T-chart, is a different thing. But yeah, synthetic method. Always, once you understand this, you'll prefer to do it. because it occupies very less space and it is very fast. And you have to divide by what makes it 0, which is 2. So at 2, that is the restriction on this, right? You say x is not equal to 2, right? So that number is your divisor. Now, first step first is basically to bring down the leading coefficient as such. So 2 as such will come here. Then you multiply 2 by 2 right here, and then you do add. Then you do add, right? As you go down, minus 3 plus 4 is 1. Multiply by 2. Minus 5 plus 2 is minus 3. Multiply by 2 gives you minus 6. When you add, you get minus 5. When you multiply, you get plus 10. And what you get is the remainder 0. You see that part. Now we do get remainder 0. That means x minus 2 is a factor of this particular polynomial. What is the quotient? Can you tell me what is the quotient now? The earlier polynomial was 2x to the power of 4. Divisor is x. So definitely this should be a cube, right? So we can write that the quotient is 2x cubed plus x minus 3x 3 minus 3x minus 5. Do you see that? That becomes our quotient. Do you see that? And what is the remainder? 0 in this case, correct? So that is how we are going to do it. And we can say, well, this particular polynomial, which is 2x to the power of 4, 3x cubed minus 5x squared minus plus x plus 10 is basically equal to the divisor, which is 2x cubed plus x squared minus 3x minus 5. You could write the divisor first or later. So x minus 2. Do you see we have factored it since the remainder was 0? Can you further factor it? We have got 2x cubed plus x squared minus 3x minus 5. So you may try to factor it later, right? But we'll leave it here because the statement is how do we divide? And you have also learned this method of synthetic division, that how do we use synthetic division to divide? Now, to all of you, is this absolutely clear?
Yes,
Correct?
sir.
Well, that is a lot of work which we have done in an hour's job. You have not only learned the division, long division, you also learned synthetic division, which is very good, as you can see. So synthetic division has a limitation that only you could divide by binomials. If there is a trinomial, then it is very difficult. I'm not saying you cannot divide. There is a different way of dividing, okay? You can watch my videos to see how do I divide by, let's say, x minus 2 times x plus 2 or things like that, okay? So we could do that, but we don't really get in there. If you have a trinomial, it is better to do long division, right? But if you have a binomial, you could do synthetic division, and in this much of space, you get your result. Do you see this? Okay, so that is how you have to do. I think now you're ready to do most of the questions from this particular chapter on polynomial division. You also understand what is polynomial division, how do we write a division statement, what is remainder theorem, what is factor theorem, and how do we do synthetic division, correct? Okay, so we'll end our class here for today. Can you please tell me, what have you learned, Hamza?
So basically, I learned how to divide polynomials using the long division method. It was kind of a review because the last time this was in like grade 2 or grade 1. So that was kind of a refresher. I also learned like the synthetic division and like the finding remainder method. So those were really interesting.
Akshat.
Yeah, sir. So I've always heard of the remainder theorem, but I never really knew how you can combine long division with polynomials, right? So today that was a really like bright topic to learn about. And also the factor theorem and the synthetic division to see how easy it makes. So I really found that interesting. And also I really like the way that you can find like the 0 and then you can plug it in and then you can get like the remainder. So I found that really cool.
Yeah. Vishruta.
I learned about how to divide polynomials, which I heard of, but like I never really knew how to do it. I learned the remainder theorem and the synthetic theorem, and it was very helpful.
Good. Mohammed.
The dividing polynomials was new to me, so yeah, I learned the I just forgot the name for it. What was it called?
Polynomials, dividing polynomials. Synthetic division?
Yeah, the synthetic division, and I never finding the remainder and everything like that.
Ankita, can you summarize? And if anybody has any doubts after Ankita summarizes, you can ask the doubts. Okay, Ankita.
Yeah, as I said at the beginning of the class, I've never heard of dividing polynomials. And so after this class, I actually got a pretty good insight of the remainder theorem and the synthetic theorem or division.
Division.
Okay, yeah.
Synthetic division.
And so as I asked the question during the class about the t-charts, I was actually surprised that we can use these kind of methods as well, because I know a lot of teachers, they don't like it when you show your work. Like, I know that we say show your work, but they like to see more of algebra rather than like the actual, explaining things with charts or anything like that. So I really liked using that method or actually seeing you doing it.
And you also figured out that we can actually find the remainder even without dividing, right? Value the
Yes.
polynomial at a if x minus a is the divisor, gives you the value of the remainder. And if remainder is 0, in that case, x minus a will be a factor. So that is your factor theorem, correct? And remainder theorem is substitute the value of a in the polynomial and get the remainder. So that is your remainder theorem. Whenever remainder is 0, it will be a factor. So they are related hand in hand. So that is what we learned today. That was great. So anybody, any questions? I like you to do all the questions from your book from this particular chapter. If there's any difficulty, do let me know. We also learned a very important formula, difference of cube and sum of cube, correct? X cube minus y cube will be written as x minus a times x square plus xy plus y square. And if it is x cube plus y cube, then the first factor will be x plus y, but then we'll have a division in the other trinomial, x square minus xy plus y square. Is this clear? Half of the questions in your book can be actually done with just this formula, a cube minus b cube formula, okay? And then you have learned synthetic division as well as long division. Try using synthetic division more and more. It becomes slightly tricky when fractions are involved. However, even then, it is much shorter, easier to do, okay? Okay then, all the best. Have a great day.
Thank you, sir. Bye.
Thanks. Bye.